All right, slide 4 is an extension of slide 3 in this rectangular garden. So there's a sketch pad down here and then a table and then an answer box. So it's same situation. Jake has 80 meters of fencing to completely enclose his garden, and he wants to create a garden with the largest area. So we're going to try to maximize it. And what's weird is that if you use the same amount of fencing, even the same amount of fencing can create all these different rectangles that have different area, which is kind of odd. So they said, what about a 10 by 30? As we know from the slide before, but boom, a 10 by 30, doesn't matter what you call length or width, that does have a perimeter of 80, and the area is calculated by multiplying the length and the width. That would give you an area of 300. Well, let's try another rectangle. So maybe we would do like something like, I'm just going to go quick. Remember, these two have to add up to 40. So what if I went like 25 and 15? Okay. Let's put just the 25 here and then the 15 here. Okay. That would make a perimeter of 80. I can check that by making sure these add up to 40, okay? I also then can multiply those two, 25 times 15 to find the area, and say, does this make a bigger area? Well, it makes a bigger area than our first 10 by 20, right? What if you did something crazy like a 5 by 35? Okay. Any combination of 40 will use all the fencing, right? So let's do 5 by 35. Okay. Oh, that doesn't make very much area at all, 175. If you recall from earlier, I mean, we could go on forever and ever and find two numbers that add up to 40, and even switching these around, right? We could switch these around, a 35 by a 5. It would still make this area of 175. We're trying to get the biggest. What's weird is the area is changing. We're going to try to get the biggest area. And if you remember, the closer the length and the width are to each other, like let's try a 20 by a 20. And you might go, that's not a rectangle, that's a square. True, but a square is a special kind of rectangle. So a square does fit the definition of a rectangle. What if we made it a perfect square, right? If we made it a 20 by 20, okay. That actually maximizes the area. And anything else you try is not going to get you any higher. And that was a takeaway from one of our lessons, that maximizing the area of a rectangle with a fixed perimeter, you get as close as you can to a perfect square. Okay, so a 20 by 20 rectangle, which is actually a square, will give you the largest area of 400 square meters of garden space. Something that's interesting, if you're like, how are we getting this number over here? We are kind of calculating it, and on the quiz, it's going to ask you. So like, what if they just said, okay, length, right? L. Don't you love it when they put letters in the table? Well, if you know the length, to get the width, we have a fixed perimeter of 80, and half of that perimeter is 40. So we know what's left for the width is 40 minus L. That is an expression of what's left over. So like we went 40 minus 20 to get the 20 left over, 40 minus 5 to get the 35 left over, 40 minus 25. And an expression for the area of the garden is we took whatever the length was and then multiplied it by the length. 40 minus L. It's a lot easier to do when there is numbers, but it's just saying, well, what do you do if you only know one number? What mathematically are you doing to anything?